Let's consider two examples of higher order differential equations. For example, let's see first the third order equation. So the third order equation is y triple prime plus 3y double prime minus 4y is equal to 0. So there is no y single prime here in this equation. So this is a homogeneous equation and linear. Its a characteristic, or sometimes it is also called auxiliary equation, is m cube plus 3m square minus 4y. So the roots of a cubic equation are difficult to find. I mean, there is no simple formula for that. But in this particular case, if we just do some simple inspection, so you can see that if we take m is equal to 1, so this term will be 1, this term will be 3, 1 plus 3, 4 minus 4, that will be equal to 0. Okay, so that will be equal to 0. So it means that m, by simple inspection, we can say that m of one of the root is m. Okay, m is one of the one of the root is 1. Okay, so that means m minus 1 is one of the factor, and then there can be some other factors as well. So the other factor we can find by the long division, simple old style division, plus 3m square minus 4, and then if I divide it, so I will put m minus 1 over here, I will multiply it with m square, so it will be m cube, and then minus m square. Now I subtract it, so this will cancel out, so it will be 4m square, this term will be 4m square, so the next term will be 4m square, so I will multiply it with plus 4m, so 4m square, and then it will be minus 4m, and then it will be subtract again, so this term will cancel out, so this will be 4m, and then I will take minus 4 over here, and now I will multiply it with 4, it will be 4m minus 4, then subtract it, and then it will, or everything will be cancelled out, the remainder will be 0. So the second factor we got over here is m square plus 4m plus 4, and incidentally that second factor is a complete square, so it is m plus 2 square. So in this way now we get one root, which is m1 is equal to 1, m2 we will get as minus 2, which is same as the m3. So we get two double roots and one distinct root. So its solution will be, from our previous experience, it will be that the general solution will be c1 e power x minus plus c2 plus x c3 cx3 c3x or x c3 e power minus 2x. So this will be the solution for this third order equation. So now let's consider a fourth order equation. So fourth order equation is y fourth derivative plus 2y second derivative 2y prime plus y is equal to 0. So its characteristic equation will be m power 4 plus 2m square plus 1 is equal to 0. So here we can see that it is a square. This equation, this right hand side is a square of m square plus 1 is equal to 0. Yeah, so we have intentionally taken an equation which can be easily squared. Otherwise, it's very difficult to find the roots for a fourth order equation. So from here we can find that m square plus 1 is equal to 0, or m square is equal to minus 1, or m is equal to plus minus I. Okay, yeah, it will not be simply plus I, it will be plus minus I, because for both plus I or minus I, the square will be minus 1. Yeah, so for example, if I take I square, it will be minus 1, that we already know. If I take minus I square, so it will be also minus 1. Remember that it is not this thing that this is equal to plus 1, but it is basically this. So both of this value and that value are minus 1. So that's why we have to take plus and minus plus I over here. So in this case, because there were four, so fourth order, we should have 4 roots. Okay, so how we can see that? So and some of the complex roots are double roots as well. So, and for the complex, we already know that the equation is in the cosine and sine terms. So in this case, the solution will be, so in this case, iota is a double root or minus iota is a double root. So it means that we see that the roots are m1 is equal to iota, which is also same as m2, or the other 3 roots are m3 is equal to minus iota, which is also same as m4. Okay, so in this way, then how we can write the solution? So if we write the solution in terms of their sine and cosine functions, in this case the value of a is 0, and for the double root we have to, just like we did for the real roots, here we also have to multiply by the x. But we can also represent it in the exponential forms, okay, as well. So like this, c1 e power iota x plus c2 e power minus iota x plus c3 x e power iota x, and plus c4 x e power minus iota x. So in this case, if you combine some terms, so for example iota x and minus iota x, so okay, so we can simplify these terms. For example, if I take this term c1, yeah, if I take this term, so c1 iota x, I can write like this: c1 e power iota x is equal to c1 cosine x plus c1 sine x, c1 iota sine x. Okay, and then c2 iota minus x, I can write c1 cosine x minus c1 iota sine x. Why here there is a minus sign? Because here the term is in negative term. So negative of cosine, so it will be a negative. It will be cosine negative x. Cosine negative x is same as cosine x, because cosine is an even function. Sine negative x over here is a minus sine x, so therefore the minus sign will come out. So this we have written for based on the Euler's formula. So if I add these two terms, So this will be here it is C2, okay, C2, C2. If I add these two terms, so it will be cosine x times C1 plus C2, and C1 plus C2 is also a constant actually, so just take it as C1, okay, so cosine x. And if I add these two terms over here, so C1 iota minus C2 iota will be the constant term. Iota, although it's a imaginary number, but it is still a constant. So that constant we can also label as C2, so sine x. So basically, by this expression I got C1 cosine x plus C2 sine x. And similarly for this, the only thing it will be that there will be an addition of x over here. So it will be C3x sine x cosine x plus C4x sine x. So this will be the solution, general solution. Let's try another cubic example. Cubic differential equation. So 3y triple prime plus 5y double prime plus 10y prime minus 4 is equal to 0. So main problem over here is to find the roots of the characteristic equation. So 3m cube plus 5m square plus 10m minus 4. So one can use the find roots function of in Mathematica, or maybe even in Wolfram Alpha. You can input this equation to find the roots, but one of the tip to finding the root is that one of the root of this type of equation can be hidden in these factors, this factor and this factor. So this is the a naught term and this is the highest term, and that can be that may be one of the factors. So for example, the factors of 4 are 1, 2 and 4. If you take plus minus plus minus plus minus, so there are 6 factors. So what are the factors of 3? The factors of 3 are plus minus 1 and plus minus 3. So the possible roots are this. So this is the a naught term, this is the a 3 term in this case, not 1, 2, 3. So the possible factors are the ratio of these. So for example, 1 over 1, ratio of this a naught to a3. So this ratio is 1. So one of the factor will be plus minus 1. Another will be 1 over plus minus 1 over 3. Another factor will be plus minus 2. Another factor will be plus minus 2 over 3. Another factor will be plus minus 4. Another factor will be plus minus 4 over 3. So these will be the possible solution. So these values are the possible solutions of this characteristic equation. So these values can be tried to input into this equation, and which value, whatever value which satisfies this characteristic equation, that will be the root, one of the root of this equation. In this case, incidentally, the m is equal to 1 by 3 is the root. So this can be verified. So if I input the value of m is equal to 1 by 3 over here, and then this can be checked. We will continue this problem in the next video clip.